So it wants an expression to know what distance up the board, right? So here, let's start with here. Well, first I know this distance up the board. I'm going to refer to it as just delta y. Delta y happy, right? So looking at this, if I were to start from the peak of the board and go downwards, I can use my displacement formula while going downwards, right? Delta y is equal to 1/2, well, whatever the a is, at squared plus vi, right? Well, if I'm going from top to bottom, right, then my vi is going to be 0, viy is going to be 0, because at the peak I know vy is equal to 0. So really, this can go away. And I'm left with that. Delta x equals 1/2 at squared. I mean delta y. So I'm going to go here. Delta y equals 1/2 at squared. Well, what is a, first of all? Well, since this is an incline, right, I know that the acceleration downwards is going to be influenced by FGY. Well, what's FGY? First off, I know this ramp, it's an incline, it has a phi, and then I know FG is going to go downwards from the whatever the object I'm shooting on here, right? There's going to be FG force downwards, but since that's not the plane of motion I'm looking at, there's going to be two components to it. There's going to be FGY. There's going to be this FG right here. And there's also going to be FGX now. This is what's going to influence that motion, that acceleration downwards. And I know this angle created here between FG and FGY is the same as the angle of the ramp, so that's phi. And using that, I know that FGX is equal to FG times what trig function? Well, FGX is opposite to phi, so FG times sine phi. I know that FGX is going to be mass times an acceleration, but mg sine phi, that's also going to have, FG is equal to mg, so then I divide both sides by m. I get my acceleration to be g times sine phi. Magnitude. Okay? So I have that for my acceleration, I can plug it in. Delta y, happy face now, is equal to 1/2 g sine phi. But what is t? Well, I can find t by using this expression. VOY is equal to, VOY minus AT is going to be equal to VFY. But in this situation, minus because it's going to make it go down the ramp. But in this situation, I know VFY is at the peak, so it's going to be 0. So VOY is equal to AT, divide A by both sides. That's going to get me T. So VOY, but what is VOY? Well, if I look at the angle, I know there's going to be two components. There's going to be a VOY, because it's the angle now, and there's going to be a VOX. If I look at my VO. Right, so I have a VOY and a VOX. And I know VOY is opposite to the angle, so VO sine theta over A. What is A? G sine phi will get me my time. So VO sine theta, not theta, phi, VO sine phi over G sine phi. It's going to be squared. That's my time. So there you have it, part A. Now part B. Again, suppose it takes the angle is known, right? Calculate the horizontal motion. Considering the horizontal motion, how long does the ball take? So time. Well, I know that delta x is equal to VOX. Doesn't really matter because Vx doesn't change times t. Right? So I know now that I can simplify, plug in my values. Right? This is VO, but VOX is cosine because it's adjacent to phi. No, to theta. That's cosine theta. This is VO sine theta. The one at the bottom is phi. Right? T. So then I know that just T over VO cos theta is equal to T. part C. How long does it take to reach the maximum height? Well, that's the T peak, right? Well, what is T peak? It's simple. I have T peak over here. This would be T peak. Because, you know, I'm using the peak as my reference point, so I killed two birds with one stone. And if that's T peak, then I know this is T peak right here. And I explained it because I went from top to bottom, right? Well, you can just reverse it, bottom, top. The time I get to go from top to bottom is the same as the time it takes to go from bottom to top. So, my T peak is just VO sine theta over G sine phi. D. The answer is part C is delta Tm. What's the time it takes to reach the target? Well, if I look at the motion, it's going to start and end at the same position, right? And I know this ramp isn't moving up and down or whatever. So it takes for me to reach the top is the same as the time it's going to take for me to reach the bottom. So I can really just multiply the time it takes to reach the top by 2. And that gets me, like, you know, T target. Okay, E. E proved that this is true. Angle should be launched is represented by this. Well, I think I would best work with range because I see this arc sine. This arc sine in this 1/2 indicates that it came from sine 2 theta. Right? So let's work with range is equal to first off vi squared sine 2 theta over G. But if I manipulate that to match what I want, I got D is equal to VO squared times sine 2 theta over G, but not G anymore. It's my acceleration, which is going to be G sine phi. Okay? Well, now I isolate for theta, multiply G sine phi to both sides. Right? Divide both sides by VO squared. So, is equal to sine 2 theta. Multiplied both sides by this, by the way. And I divided both sides by that. Which is why, see, division, and then multiplication. Anyways, now I have that. Now I can do arc sine. For the arc sine of that giant monstrosity, which is dg sine phi. Over VO squared. And then 2, divide both sides by 2, same as multiplying by 1/2. I have theta equals 1/2 arc sine of dg sine phi over VO squared. Is that true? Let's compare it. Oops. Theta equals 1/2 arc sine. dg, gd, synonymous. Here, I can move it for you if you want. gd sine phi VO squared. Yep, same. Proved it. Now, if the angle with the flat board would increase, how would the answer part A change? Well, let's go to our Hmax equation, actually, because it will be easier to see the impact that way. Hmax is equal to, I'm just going to alter it for the problem, VO squared sine theta squared. Like so. Well, actually, it'd be nicer if I did like this. Sine squared over this 2 times the acceleration, which is not g, but rather g sine phi. Okay? So, let's check g sine phi was my acceleration, yeah? So, with this Hmax equation, right, I know that as sine increases angle, well, I know that the angle can see the lowest the ramp can be is just a little bit above 0. and the highest the ramp can be is angled at 90 degrees, right? And as per our unit circle, as we go up this degree, boom, boom, it's going to go from 0 to 1, right? That's what sine of 0 is. Sine of 0 is 0. Sine of 90 degrees is 1. So as I go up an angle, right, sine is going to increase. But as I increase this sine phi value, right, as this goes up, I'm going to be dividing this by a larger number, and hence that makes this go down. So the answer would be decrease. And it makes sense because if my ramp is to be steeper, right, gravity FGX is going to be working more intensely on it rather than moderately, or rather than lightly. Oh, that's a bad ramp. But you get the idea. Rather than lightly or moderately, it's going to be working intensely on it as I increase my phi. So as I increase the angle of the flat board, right, the object's going to want to go down more. And with the same speed and everything, it's going to decrease how high I can really go up on that object, because I'm going to need more velocity initially to get that same height if I increase the angle, because the ball's going to want to go down more due to the FGX's acceleration acting on it. So it would decrease.